So for example number 4, if I have a circle, a perfectly drawn circle, and we'll call the center of this thing E. That's a crappy letter. So this is E, okay? And then I have a line AB, or I have a chord AB that kind of goes like this. And then I have a line CD that kind of goes like this. So this is AB, this is CD, and then I have a radius that goes like this, so that this is perpendicular to here, and this is perpendicular to here. Then, in other words, if I say if AB is congruent to the line segment CD, or the chord CD, not if. AB is congruent to CD if, and only if, EF is congruent to EG. So this is F, and this is G. So if I have an image where this is congruent to this, okay, then this chord is congruent to this chord. And that's called the equidistant chord theorem. Now, they're equidistant from the center of the circle. So this is my circle E. This is the center. This chord, because we're drawing a line from the center of the circle to this chord such that it intersects at a 90-degree angle, and we're doing the same for this one. If these two line segments, this line here is congruent to this line segment, then that means these chords are equidistant from the center of the circle, which means that the distance from here to here is the same as the distance from here to here. Okay? So now I'm going to draw another crazy circle, and then we're going to do the problem. So example 4 is really this. I have a circle C, and a line here. This is W, this is X. I have Q and R, and then I have S, and then I have T. Okay? And then if I draw a line from here, that is a 90-degree angle with that line, and then this just naturally is 90 degrees here. It doesn't look like it on the screen because I don't know why the document camera kind of skews the image, but that is the case. And then from Q to C is the radius. Okay? And we're told that this distance here, is 5x minus 9, and then this distance here, from here to here, is 2x. Okay? And they tell us some information. They say that because, this is all in the textbook, but I'll write it down in the notes. So we can only prove this, we know that we're going to set this equal to this. Okay? But that's if this stuff is true. So what they're saying is, in the diagram, QR is equal to ST is equal to 16. Alright? And then CU is equal to 2x. And then CV is equal to 5x minus 9. And they want us to find the radius of the circle C. Okay. So now this is not that hard. Um, oh, I got to label some things. So this intersection here is V. This point, this intersection, so if this is a point, that's V. This point here is Y. This point here is U. Okay? And so in order to solve this, I know for a fact that CU, because the textbook tells me that, equals CV. So if I say CU equals CV, then I'm going to say CU, which is actually 2x, is equal to 5x minus 9. Okay? So let's solve for x, because we're going to need to know that. So then what I can do is I can subtract 2x from here. That gives me 0 equals 3x. And then I can add 9 to both sides. I'm writing kind of small because I want it all to fit. So I get 9 equals 3x, so then x equals 3, right? Because you would divide both sides by 3. So x equals 3. Boom. So that means that CU is 2 times 3, which is equal to 6. That means that this over here is 5 times 3 minus 9, which is 15 minus 9, which is also equal to 6. Okay? Alright. Well, that's good. But they're asking us to find the radius, which is actually QU. Right? And then, well, actually, CQ is the radius. But if I can find QU, that's going to help me, because the radius, this, if you look at this is a right triangle, right? So in other words, I've got this triangle here. I'm going to sketch it over to the side a little bit. This is kind of, it's not a hard problem, but I can see where it'd be confusing. So this would be U. So I'm taking this little triangle and I'm sketching it off to the side. And this would be Q. And this would be C. So that's a right triangle. I just figured out that this was 6. So now this is the radius R. Right? From Q to C is the radius because it goes from the center of the circle to Q, which is on the edge of the circle, right? So that's really technically the hypotenuse of this little triangle. So if I can find this distance QU, I can use the Pythagorean theorem, blah, 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 blah. Well, what do we know? We know that Q to R is 16. We also know that it's that chord is being dissected or bisected by the diameter such that it's a 90-degree angle. So that means that QU is equal to, in other words, this is congruent to this. QU is equal to 1/2 times QR. Well, we're told here that QR is equal to 16. Okay, that was given to us. So I'm going to say that QU is equal to 1/2 of 16. So QU equals 8. So I've got an 8 here. Now this is the hypotenuse. R is the hypotenuse, which is the radius of the circle. So in other words, to find R, I'm going to say that R squared is equal to 8 squared plus 6 squared. Okay? So then R squared is equal to 8 squared, which is 8 times 8, which is 64, plus 6 times 6, which is 36. So then R squared is equal to 100. I'm going to take the square root of both sides, and I get R is equal to 10 times 10 is 100. And that's it. That's how it seems like a lot of work. It is, but that's how you do that.